Right, we're gonna carry on with you've got step down part there. Okay, we're gonna carry on with this, but we're gonna go to the top. 1 second. Right, so we're gonna look at this again quickly. You have your soft iron core. You've got a coil wrapped around the first part. That's called the primary. That's the primary coil. Right, it has a voltage, so that's the primary voltage, and it has a number of turns, which is the number of turns on the primary coil. On the other side, the output side, so that was the input side, this is the output side, you have another coil which has the number of turns, which is the NS value, which is the number of turns on the secondary coil, and it has a voltage induced on it, which is the secondary voltage. The formula is that you need to be familiar with number of turns on the primary divided by the number of turns on the secondary. So that ratio is equal to the voltage on the primary divided by the voltage on the secondary. Right. What else are we going to say? Right. If there are less turns on the primary and there's more turns on the secondary, it is called a step-up transformer. If it was the other way around, if you had lots of turns here and a few turns on the secondary, it would be a step-down transformer. That means the voltage goes from, if it's step down, the voltage goes from high to low. What's going on here? Right, we also need to know the voltage and current in the primary and the voltage and current in the secondary. So this is the formula linking it. So remember, we know this, don't we? We know that power equals IV PIV. Power is current times voltage. This is what we've got here. The power in the primary is equal to the power in the secondary. You're assuming if it's 100% efficient. There's no heat losses. Right, okay, so let's move back down to the next question. Right, okay. So here's a halogen lamp. Here's a power of 50 watts. Calculate the amount of electric energy transferred in 40 hours. So we need to convert hours into 40 hours equals 40 times 60 minutes times 60 seconds. That's a lot of seconds. So we've got that in seconds, what we need. We know the formula for energy is power times time. So power is 50 watts times 144,000. If you put that into your calculator, we get 7.2 million, 7,200,000 joules. Let's make a note of this. It looks like it's going to be useful for us. So, right, let's fly up. So, let's do something like this. So we know energy equals power times time. Right, cool. Let's go back and continue on. Right, student noticed that in addition to producing light, that lamp gets hot. The student concludes that it cannot be 100% efficient. Is the student correct? Yes, the student is correct. The student is correct. Why is the student correct? Because electrical energy is lost to the surroundings and doesn't go to light. Surroundings as thermal energy. So light energy is less than the electrical or input energy. Nope, nope, don't do it that way. Okay, that's what they say. There's 2 marks, so yes, they're correct because energy is lost as thermal energy as heat. Yeah, that's why it gets hot. So that means that the light energy is not going to be as much as the electrical input energy. You're going to always get losses. Right, okay, this is the one. The lamp must not be connected directly to the mains voltage. A step down transformer must be used. Describe the structure of a... Oh, okay, this is the one that I was on about. So let's draw it from memory. So we've got a soft iron core. A step down. So if we draw 1, 2, 3, 4, right? So this is the input. You've got an AC supply. You've got input voltage, which is called the primary voltage, and you've got the number of turns. Yeah, you may draw a diagram. Okay, that's fair enough. Now, because it's stepped down, I'm expecting, so here I've got 4. On this side, I'm going to draw 2. Because it's stepped down, so I'm going to just go 1, 2. So this is output. You've got alternating voltage and current. You've got voltage secondary, and this here is the number of turns on this side. I'll put it down here is S. So we've got 2 cores, we've got the iron core, we've got more turns on the primary than the secondary. Yep, that'll do it. So it's important that, well, it's good to know that anyway. I'm going into an exam. Right, the step down transformer reduces from. So look, from is your voltage primary, 2 is your voltage secondary. The current secondary, IS. So we need an equation. So we said, all right, remember we said power equals PIV. Yeah. So the input power will be primary current times primary voltage equals secondary current times secondary voltage. So now what all we do is substitute the values in. So we know VP, we know, oh my god, that's supposed to say S. I can't believe this. What happens, you become blind to the board. VS, we know that. We know secondary current, we know that. So this is the one we're missing. So we put IP times VP is 230. IS is 4.2 times VS, which is 12. We rearrange it. Remember, we've gone into physics mode. And then we just write down the answer. According to the mark scheme, it's that 0.22. Okay, that's cool. Ooh, that's all we got. I think I'll have to find some more of these. But is there anything we need to write up here? Nope, that's it. So if you can learn these, you're on to a winner. Yep. Right, okay, well done.